Hello everyone, my name is Jake Sharp. I work out of the Petrosys Houston office. I'm excited to be able to present the newest version of Petrosys, that's 17.4 to you, or at least introduce you to some of the kind of new features, key things that we've been up to, show you how you can utilize these new features in your current workflows, and they're really going to streamline the mapping and gridding process. So real quick here, let's just mention what those key features are. So I'm going to be kind of showing you this new idea that we've had called mapping without borders. It's basically taking the requirement of a map sheet out. So for our current Petrosys users, you normally had to basically set up your AOI, scale, and CRS prior to getting in and actually adding data to the map, actually starting to map your seismic and wells. We've removed that need so that are able to basically create these dynamic maps, as well as a couple other new things in the mapping, 2D mapping module. We also added some improvements to the surface modeling, mainly around the ways of importing stacking velocities and then how you can utilize grid arithmetic to do some depth conversions. Also, the import of checkshot surveys directly from your third-party data stores. So it's another really handy thing to be able to do. It's really going to streamline the way that you bring data into Petrosys so you can utilize it for these depth conversion operations. Finally, we've also made a couple big improvements to the functionality in the 3D viewer, specifically being able to display point data inside the 3D viewer. And whenever we were designing this, we were keeping in mind that this is a really common way of viewing microseismic. So I'll show you how you can utilize the 3D viewer now to view microseismic type data from spreadsheets, as well as adding support for oblique clipping planes, or the ability to draw oblique clipping planes or reference planes inside the 3D viewer. So now you'll be able to set that clipping plane up so that it's perpendicular to structure. So you can display a bunch of grids in the 3D viewer and then draw these clipping planes however you want, or a little more freedom to draw these at different angles now. So that's really, really handy. There's also some really significant performance improvements in terms of how the 3D viewer works. In the background, kind of behind all of this, we've updated it so we now supply a 64-bit version of Petrosys. We still have the 32-bit if that's required, but we have a 64-bit also. What that's going to let you do is it gives Petrosys access to more memory, so you can utilize more massive seismic surveys, higher resolution, larger sized raster imagery, larger well data sets, that kind of thing. And this lets our developers work with a little bit more in terms of future development and being able to optimize Petrosys to run smoother on nice machines that I'm sure everyone is using. So what I'm actually going to do is just go through a normal Petrosys workflow. Nothing super new in here other than highlighting how these new features are going to speed everything up. So we'll be able to go through pretty much the whole Petrosys workflow in a couple minutes, or one of the common Petrosys workflows. That's mapping some data, so connecting out to a third-party store, as well as bringing in some regular kind of file-based data. We're also going to go into gridding and contouring, show you depth conversion operation, show you how these new import options work, and then get into, after creating those depth converted grids, get into the 3D viewer to do a little quality control, and I'll highlight some of these new features in the 3D viewer. Finally, we can go back into the 2D map, and I'll show you a couple other little improvements we've made to getting the maps out. So small tweaks to the printing and plotting options that should make everybody pretty happy. So let's get right into the Petrosys software demonstration here. So I'm just going to jump right over to my Petrosys map. You'll notice that my Petrosys map here, this is basically what you're going to see now if you go in and start up a brand new Petrosys project and you haven't selected a map sheet before. What you see is a dynamic map sheet option. So what this means is now I can just go out, grab a grid, say a grid that I've created previously, or gotten from one of my friends, colleague down in the hall, anybody here. And what Petrosys does is once I display that grid, it automatically sizes the AOI and sets a scale and the CRS to fit this grid. It's not just grids, of course, so I've also got a, let's say just a set of files. So I've got a Excel file over here with some well tops and some other information. I can just drag and drop that right onto the map. It's going to utilize the CRS that I was using previously to display the data, and then expand the map sheet out so it captures all the data. One thing to note here is that's a really good QC tool. If you know the area you're working in should be a certain size, if there's a point that lies far out here, it's going to expand extra large. You'll see everything. So you'll notice if you have a couple bad data points. This also works for our third-party connection. So if I go into the 3D seismic, I can go and basically pick up display from, say, a Kingdom project, IHS Kingdom project. I've got a 3D survey in here that I can grab that has a couple time horizons that we can utilize for this workflow. So you see when I add that, it expands just a little bit, so it keeps expanding. The AOI gets a little bit bigger. If I remove a couple layers, this dynamic map sheet is going to actually resize. So as you move layers in and out and move data in and out of the map, it actually resizes and rescales for you. So you don't have to worry about it. If I do, say, want to stick with a certain specific setting, I can actually save the map sheet. So this is still dynamic, but if I want, I can go to map sheet, save as, and basically pick up a template from another, so the style from another one of the map sheets that's saved in the project if I have one. Otherwise, it will just use some defaults. We'll set the border type to projected, and then I'll just click OK. And what that does is you can see now it's basically staying put. If I turn off my 3D survey, you'll notice the map sheet doesn't resize automatically anymore. So as I move data in and out now, it works just like it did before. It's just a regular old map sheet. I can go in and edit the scale and change things if I need to resize stuff. Another big improvement we've done here is fixed, or basically made it a little bit easier to create bubble maps. So we've added the Excel file as one of my input options for bubble maps. So if I go and have, say, some bubble maps that I'd like to use, say just a little bit of production data, and maybe I want to make bubbles off of the oil, I can go out, grab that oil column, utilize that as one of my attributes. Let's give it a color fill here. We'll just make it green. And you can make more complex bubble maps than I'm going to do, but you don't want to spend too much time here showing you how to do this. If you add more attributes in here, so if I added the water and the gas column, it's going to make a pie chart bubble map. But if I just leave it basically using the defaults and just have it based off of a single one of these attributes, it's sizing according to how much oil is getting produced at each one of these well locations. I've also set up some annotations so it shows me how many barrels are coming out. And just something to note here with the new basically dynamic mapping options is now I've got this display, my annotations are a certain size. If I jump out to a differently scaled map sheet, so let's go out to a more regional size map sheet. In this case, we're going to utilize one this is the entire state of Wyoming. You'll notice that I've still got a little speck on the map, so it's very, very tiny. If I zoom in on that layer, my smaller grid layer, we'll see that the actual annotations and the bubble sizes, whereas before they were based on the scale of your map, but now we've updated them so that they stay sized according to the world coordinates. So your annotation size is basically the same size on this larger scale map sheet as it was before. So I can kind of zoom in and zoom out, and all my annotations are staying how they had been. So that's really, really handy tool for being able to create large regional maps for a lot of data that's spread out over a lot of different areas. And I can kind of jump around and zoom in and still be able to read all my annotations. And I'm switching between map sheets with different scales. So those are some of the new mapping options. If I jump right over into the surface modeling, let's just bring that guy over here and move this Windows Explorer. So surface modeling, Windows still looks the same. What I've done here is create a nice depth conversion workflow for two different horizons that we're bringing in from the IHS Kingdom project. The first thing to note here is I'm importing the stacking velocities. So we added an improved interface for this and an improved way of formatting ASCII stacking velocity files, but in 17.4 we've also added the option to import directly from segY. So if you have a segY file, you can go grab that and import the data from there. My stacking velocities in this case have to be stored in a text file, so it's picking up the formatting option. I can do a little preview so that I can see what my stacking velocities look like. Each of these lines that are stored in the file. Okay, once I've imported the stacking velocities, we can calculate average and interval velocities to different two-way time values or horizons inside the SDF. Once I have those calculated, we can go out, grid time, grid average velocity, and then go into a grid arithmetic to utilize a depth conversion workflow. Basically multiplying my time horizons against my velocity surface. A couple improvements in here that you'll note. First off, if you're doing a lot of editing in this formula window, you can expand that very, very easily now, so it gives you a little bit more room to breathe. Also, if you've created your own custom formulas, we've made it very easy to save those at this project or site level. Save it to the site level, what that means is I have new templates available, so you can basically create your own template groups for group arithmetic at the site level, and I can add in my own templates that weren't available to me before. So in this case, I can say add in a bit of a nice fancy conditional statement. So that can be very handy if you have some power users who are making advanced formulas. Now it's going to be much more available to all the users. So we'll cancel those changes. I'm just going to let this whole workflow run. It's going to go through and basically update my models. So importing stacking velocities, gridding my time horizons, as well as my velocities that I just calculated over the area. Utilize both of those new grids to do some depth conversion. So I'm using grid arithmetic to do the depth conversion. And then I'm finally going to tie my depth conversion grids back to some well locations. Picks that I had at my wells in one of those horizons. Nice thing about the well tie, if you haven't used that in a little while, since 17.3 was released, we added some mistie reporting to the well tie functionality. What that means is you actually get a nice spreadsheet showing you what the differences are between your well data and your depth converted horizons. So it produces this little report here. You can see that this is really good for QCing your well and depth converted grids. I can actually highlight wells that may have 1,000 foot of correction. I could go back and make sure that this well actually has all the correct values, and also make sure that my seismic picks around that area look really good. Okay, so now I've generated my seismic surfaces. So if we go into QC mode, I'm going to open up my 3D viewer, and in the 3D viewer I can just open up a file that I created previously that's going to display those two grids that I just created. So grid number 1 and grid number 2 will appear here in just a second. Alright, I'm zooming into my last used viewpoint. What you'll also notice here is I've got a clipping plane displayed. So we've always been able to have our grids and clipping planes displayed in Petrosys. Move those back and forth along the y-axis. What we've done to improve these now is added the option to do a little bit of rotation in here, or a lot of rotation, all 360 degrees if we need to. What this is really handy for is, first off, I can now make my cross-sectional view totally perpendicular to the structure, so it doesn't only work with north-south or east-west directional trends, but I can move it back and forth. What we could also do here is line that up to, say, the fault plane, so the direction of the fault plane, and then move that in there so it basically overlaps with the faults. And now I can view a cross-section along that plane and compare my multiple grids. You also notice that I've displayed a little bit of point data over here. So the point data, this is really just showing my tie points from this bottom grid to my well location. So that's one use. There's lots of different uses for the display of points in 3D. And another really great one is just being able to display, I mentioned the seismic data. If I switch over to a different project, I have some better microseismic that I can show you here. And once this guy opens up, I'm just going to open up a single well display. And so you'll notice along this horizontal, if I zoom out a little bit, we can display some point data along the map. But this time, the point data is actually multiple stages of a frac job. And you can see here's the microseismic events associated with each of those different stages. You can see the symbols of these little spheres have been sized according to the, the amplitude of the, or the magnitude of these events. So all kinds of different things you can do here. Once you get your hands on this, I'm sure you'll be able to think of other ways. Displaying point data in 3D Viewer will be useful to you for QA and presentation purposes. We switch back over to my other project. I'll show you one final thing, and we'll say open up an example of a nice finalized version of the map. So once you've got all of your map layers and grids and contours and faults, a note about the faults. Fault handling has been improved. We've also added some more integration with fault risk. So if I click on a fault, you have a couple extra fault risk options in here to feed this fault polygon out into fault risk. But you'll also notice if you zoom in on some faults, the way that we assign top and bottom in the apexes, so how we display fault symbols has also improved. So if you've noticed issues with that in the past, you should see a lot better handling of fault symbols, making sure fault symbols don't wrap all the way around faults now. If we go out and use some of our export options, like the export to PDF option, see we've added a preview function here. So you actually get a little print preview, and what that means is you see an example of what you're going to be either plotting or printing out to a raster image. So that's, you can see in new, and so we can use that to save things out to, say, a PDF or a georeference raster image. And we also still have control over all the resolution settings and all of that. So this is most of the kind of key feature changes. Notice, one of the really big ones is that ability to, basically, you don't have to define your AOI before you get going. You jump right into mapping, just start dragging and dropping data onto your map here. So that speeds things up. We get into gridding and contouring. So again, much easier. You don't have to reformat your stacking velocity ASCII files, or even if you don't have those, you just have it in SegY. We can read that in directly now. Work those into your custom grid arithmetic formats. They're getting saved at the site level. And then finally go back into your map. You can print these things out, get the print preview. So it's nice and easy. So you can create these nice looking PDF files, layered PDFs that we've been supporting for a while now. So we can put these on and off here. So that is most of the big changes. If we jump back over to my PowerPoint presentation, there was some other things that I didn't have a lot of time to mention. I didn't have time to quite go through and show you examples of. Stuff like being able to import and export the vertex files, little improvements there. Other little improvements to mapping, added support for a couple newer versions of the third-party connections, so Paradigm 2011.3. That's a big one because we've added support for viewing Paradigm from Petrosys on Windows, support for Sizeware 8.0, and then also support for ARC 10.2, as well as supporting the Esri ASCII grid file import and export. So that's a new import-export option. There's a lot of other little tweaks and added functionality in 17.4. I would encourage you to go ahead and read through the release notes whenever you get the new version, or you can go grab those release notes off of our website, which is just www.petrosys.com.au. Otherwise, just remember, you can utilize all these new functions in the new version of Petrosys. Hopefully it's going to speed everything up for you and just make it a lot easier to jump right in and get apps created, handling more data types faster, quicker, a little bit easier for you. Definitely, if you have any questions, send them over to info@petrosys.com.au, or you can send them to our US support line, support@petrosys-usa.com, or just send them to the general support at petrosys.com.au. Otherwise, thanks a lot for your time. Really happy to be able to show you all these new features in 17.4, and please let us know what you think. Thanks.